students, from last class onwards we are discussing the lesson motion. Okay, so what is motion? If the object is changing its position with respect to its surroundings, okay, then the object is said to be in motion. Okay, changing its position with respect to surroundings. Okay, so if the object is changing its position with respect to surroundings, then the object is said to be in motion. Okay, so what about rest? If the object is not changing its position with respect to surroundings, okay, no change in its position with respect to surroundings, said to be at rest. Okay, so based on the path taken by the bodies in motion, we classified motion of bodies as three types, right? We already discussed in previous class. Okay, types of motion. Okay, translatory motion, rotatory motion, and oscillatory motion. We can consider one more, random motion also. Okay, random motion also. If the bee or housefly will travel from one position to other position, right? It move from one position to other position. It will take a random path. Okay, so the path taken by a bee is said to be a random motion. Okay, oscillatory motion, example, swing, and simple pendulum, because the to and fro motion of a object is said to be oscillatory. Rotatory means motion of all the parts of a moving body follows a circular path with respect to center or a fixed axis. Okay, rotatory motion, example, wheels. Okay, wheels, and you can consider even earth. Okay, so translatory means if the all the parts of a moving body takes a straight line path, then it is said to be in translatory. If that is circular, then it is said to be curvilinear motion. Okay, these are the four types of motions. Okay, so next what we discussed, so let us consider rest and motion. We'll discuss in a detailing. Okay, so let us consider a moving car. Okay, so in this car, three members are traveling, a family of three members, a father, mother, and a boy. Okay, so you are the observer, you are standing beside a road and you are observing these three fellows. Okay, let us consider this is a car, and here three fellows are traveling. Okay, three members. So you are standing beside a road and you are observing a boy in the car. So is that boy is said to be in motion or at rest? Okay, you are the observer. Then the boy is in motion, right? Because the car is moving. Okay, so the boy also sitting in the car will move. Okay, so if the parents are observer, okay, his parents are observers. observers, then the boy is said to be at rest. Okay, so with respect to his parents, these all three are sitting in a same car. So is this boy moves? No, he's said to be at rest with respect to his parents, but with respect to you, if you are observer, then the boy is said to be in motion. From this example we can consider that rest and motion are not fixed, right? Okay, so these are changing based on the observer. Okay, so rest and motion are relative. Okay, rest and motion are relative. It's all based on the observer, right? Okay, it's all based on the observer. Okay, so in the previous example, the car example, if you are the observer, the boy is in motion. If his parents are observers, the boy is at rest. Means here rest and motion are two things which are not fixed. Okay, these are depends on the observer. Okay, so let us consider a house. Okay, and a tree. So whether these house and tree are said to be at rest or motion, those are, you generally give the answer, those are said to be at a rest because those are not moving. But if an astronaut is observing this house and this tree from the space, is these two are said to be motion or rest? They are said to be in motion because earth revolves around the sun, right? So earth is in motion, means that all the things or objects or animals which are on the earth are said to be in motion, right? So if the astronaut is the observer, then these house and tree are said to be in motion. Okay, if the person or you are observing these tree and these house from the earth, then these two are said to be in motion, right? Okay, if you are on earth, okay, or observer, then these two are at rest. Okay, so if a person in space is observer, then these are said to be in motion. Okay, so now you understood very clearly, right? Motion and rest are relative. Okay, those are not fixed. Okay, clear? So just now we discussed some examples, right? Car wheel. Okay, so car wheel, suppose this car is traveling in a straight line. So here what are the motions you can observe here? Rotatory plus linear, right? So here these car wheel or car wheel or any wheel is said to be in mixed motion, right? Mixed, here both linear and these rotatory motions are we can observe, right? And earth, what about earth? Rotational and curvilinear or circular. Okay, so here also mixed. Okay, so these two are said to be in mixed motion, not any type of motion. These are said to be in mixed. Okay, so let us consider distance. Okay, so what is distance? Distance already know very well, right? In physical terms or in physics, what is distance? Total length of a path traveled. Okay, so total length of the path traveled. Okay, so total length of a path traveled is called distance. Okay, so distance is a scalar quantity. Okay, So total length of a path traveled by a person or any object is said to be a distance traveled by the particular object. So distance is a scalar quantity, means we need only magnitude to define this distance, no direction. We need no direction. Okay, so units, SI units is meters and CGS units is centimeters. Even we measure distance in kilometers also. Try to consider this example. A person is moving from, okay, moving from A to C. Okay, so the distance between A and B is 3 meters, sorry, and B to C is 4 meters. Okay, so distance is equal to how much here? 4 meters plus 3 meters, total is equal to 7 meters. Okay, this is the distance traveled by this particular person. Okay, so what is distance? Total length of a path traveled, it is a scalar quantity, units is meters, SI units. So this is about distance. Okay, so what is displacement? Shortest distance from initial to final position. Okay, shortest distance. Okay, so it's consider as, let us understand the definition properly. Okay, so same example I'm considering ABC, 3 meters, 4 meters. Okay, shortest distance is nothing but this becomes the displacement. Okay, this is the shortest distance. Okay, displacement. How to calculate this? Let us consider this is hypotenuse, this is a right angle triangle. So in right angle triangle, hypotenuse square is equal to side square plus side square, 3 square plus 4 square, that is 3 square 9 plus 16, that is equal to 25. H is equal to under root of 25, H is equal to 5 meters. This is the displacement. Okay, so displacement is a vector quantity. It is vector. Vector is nothing but we need both magnitude and direction. Okay, so here north, south, east, west. So which direction is boy is moving? He is in northwest. So northwest. 5 meters northeast is the complete answer for the displacement of the this boy path. Okay, so shortest distance from initial position to final. Okay, it's a vector quantity. We need both magnitude and direction to define a displacement. So for the same example, we are finding displacement like this. Okay, by using Pythagoras theorem. Okay, Pythagoras theorem, in what is Pythagoras theorem? Hypotenuse square is equal to side square plus side square. Here hypotenuse we don't know, displacement that is only 3 square 9 plus 4 square 16, that is equal to 25, under root of 25, 5 meters. We have to mention direction also, northeast direction. So displacement is equal to 5 meters northeast. Okay, so clear, like this we'll find the displacement. Next, what is speed? So you know very well speed is equal to distance by time. Okay, so in SI units, meter per second. Even we can express the speed in kilometers per hour also. Okay, so let us consider the same example. The same person is moving from A to C, okay, through B, 3, 4, okay, meters. Here what is the distance? In the previous example we already found, right? 7 meters by time is taking the whole the path 2 seconds. Okay, 2 seconds, that is equal to 3.5 meter per second. This is the speed of the person. Okay, so this is speed also a scalar quantity. We don't need a direction to define a speed. Okay, we need only magnitude. Okay, magnitude means nothing but this value. Okay, 3.5 is said to be magnitude of this particular speed. Okay, so next, velocity. Velocity is nothing but a displacement by time. Okay, same example. Okay, so person 3 meters, so same time 2 seconds, 3 meters, and displacement we already found in the previous, that is 5 meters and 2 seconds. Here whatever, how much you will get, 2.5 meter per second northeast. Okay, so velocity is equal to 2.5 meter per second northeast. Okay, now so this is a velocity. So now we understood clearly about the velocity and speed, right? Speed, remember, s scalar. Speed is scalar, velocity vector v. Okay, v s s. Okay, thank you.